Today we're going to study addition and subtraction of rational expressions with unlike denominators. Let us see the steps how to add or subtract rational expressions with unlike denominators. Step 1. Find the least common denominator or the LCD. Step 2. Rewrite each rational expression as an equivalent rational expressions using the LCD. Step 3. Add or subtract the rational expressions. Step 4. Simplify if possible. Let us have example 1. Add the rational expressions. The first one is 1 over 12a cubed b squared plus the second is 5 over 9a squared b cubed. Let us have the step 1 to find the least common denominator. First, we are going to collect all the denominators in here, and then we are going to factor out. For the numbers, we're going to put the prime factors, and for the variables, we'll just list them as it is. So the 12a cubed b squared, this is equal to, for the 12, it is now 2 squared times 3 times the a cubed times the b squared. For 9a squared b cubed, it is now factored into 3 squared times a squared times b cubed. By the way, we are putting the common factors in one column. You see here, we put the factors of the same base in a column. Next, we're going to bring down all factors. For numbers or variables of same base, copy that with highest power. Let's begin with the 2 squared. There is no 2 factor in the second denominator, so we just copy the 2 squared. For the 3, we have here 3 with exponent 1 and 3 with exponent 2. We will copy the 3 squared. For the base A, we copied here the a cubed because 3 is the highest. For the base B, the b cubed, we copy down here because the number 3 is the highest. So this is now our LCD. We'll just take the simplified form. The 2 squared is 4 times 3 squared is 9. So 4 times 9 equals 36. And then we copy the a cubed and the b cubed. So the next step is to rewrite each rational expression as an equivalent rational expressions using the LCD. For the first denominator, I am going to multiply this by a value so that it will be equal to the LCD. The 12 here, I should multiply by 3 so that later I will get the number 36. For a cubed, it is also a cubed in the LCD, so there is no issue for the a. For the b, here it is squared, so I need to multiply this by b so that later I will get a b cubed to be the same with the LCD. So it means the first denominator I should multiply by 3b. So this 3b should be copied in the numerator so that the first rational expression is to be multiplied by 3b over 3b, and this is a fraction equal to 1. For the second rational expression, also we want our denominator to be equal to our LCD. So this 9 I should multiply by 4 to be equal to 36. The a square, our LCD here is a cube, I should multiply by a. For the b cube, it is also b cube in the LCD, so there is no issue for the b cube. It means to say, I need to multiply the denominator by 4a so that it will be equal to the LCD. And this 4a I should copy in the numerator. So our rational expression will be multiplied to 4a over 4a. And this fraction here is equal to 1. It will not change the value of our fraction. On the next step is, I will now multiply the corresponding fractions. In the first group, 1 times 3b is 3b. If I multiply the first denominator by 3b, it is now equal to the LCD. And then plus 5 times 4a is 20a all over. This denominator multiplied by 4a is now equal to our LCD. Now we can go to our step 3 to add the rational expressions. We have now two rational expressions here with common denominator. It means I can simply add the numerators. So 3b plus 20a is now here in the numerator all over the common denominator, which is the LCD, 36, a cube, b cube. And this is our final answer. Let us have example 2. Subtract the rational expressions 4 over x squared minus 6x plus 5 minus another rational expression 3 over the trinomial x squared minus 7x plus 10. Obviously, we have a different denominators here. We will follow the step 1 to find the least common denominator. We copied the denominators here and we will put now the factors. The x squared minus 6x plus 5 is factored out into x minus 5 times x minus 1. The x squared minus 7x plus 10 is equal to x minus 5 times x minus 2. Let us rearrange our factors so that the common factor will be in a column. And then we're going to bring down all the factors. For any common factor, copy it one time only. So for the LCD, look at the x minus 5. It is a common factor for both the denominators. So I will copy it one time only. And then the x minus 1, I copied here. Also the x minus 2 is now here. So the LCD is just to put these three binomials together. We have now our LCD. We will go to our step 2 to rewrite each rational expression as an equivalent rational expressions using the LCD. Take note, we should keep the LCD in factored form. Let's go back to our problem here. First, let us rewrite the denominators as factors. So this one becomes 4 over the factors x minus 5 times x minus 1 then minus this trinomial. The factors are x minus 5 times x minus 2. Of course, the numerator 3 is copied here. For our first rational expression, the denominator is here. We want to convert this into the same value with the LCD. So you see here, we have two binomials here, while our LCD has three binomials. We should multiply this denominator by x minus 2. And the same x minus 2 should be copied on top so that this value or this fraction will be equal to 1. So it means our first rational expression is to be multiplied by x minus 2 over x minus 2. And then minus the second rational expression is copied here. Again, our denominator is here that we want to convert into LCD. So we have two binomials here, while our LCD has three binomials. We are going to multiply the denominator by x minus 1. And this x minus 1 should be copied as the numerator here. So the second rational expression is now multiplied into x minus 1 over x minus 1. And then we will now multiply the corresponding fractions. So 4 times the x minus 2, we'll just put them together. In the denominator, it is now equal to the LCD. And then minus the 3 times binomial x minus 1, we put them together. And then in the denominator, it is now equal to our LCD. And then simplifying, it is now 4x minus 8 in the first numerator. In the second numerator, it's now 3x minus 3. Let us have the step 3 to subtract the rational expressions. We have now here two rational expressions with common denominators. So we can now operate in our numerators, put them together. So 4x minus 8 is here, and then minus the second numerator, the 3x minus 3. There is a note that we should always put this into a grouping symbol, because later we are going to remove the grouping symbol and we need to change the sign of all the terms inside this grouping symbol. So we have now here negative 3x and then positive 3. Let us now combine the 4x and this negative 3x becomes x. This negative 8 and positive 3 is now combined into negative 5. Step 4, we can simplify if possible. I observe we have here x minus 5 in the numerator. We have also x minus 5 in the denominator. We can cancel it, and then we will collect the remaining terms. In the numerator, it's 1 all over. There will be two binomials in our denominator, the x minus 1 times x minus 2. And this is our final answer. Let us go to example 3. Simplify these three rational expressions. Let's have the step 1 to find the LCD. Let us list all the denominators in here. And then let us factor one by one. For the u minus 1, it is already in simplified form, so we'll just copy it here. For the u, also it is already simplified, so we'll just write it again. the u square minus u, there is a common factor of u, so we pull it out. And what remains in the first term is u. What remains in the second term is -1. We wrote the common factors in a vertical column. And then we're going to bring down all factors. For any common factor, we will copy it one time only. So you see here the u is common. We will copy it one time. Also the binomial u minus 1 is common in the first and the third denominators, but we will copy it only once. So this is our LCD. We will go now to step 2, rewrite each rational expression as an equivalent rational expressions using the LCD. So let us keep the LCD in factored form. Going to our problem here, let us rewrite it first in such a way that the denominators are in factored form. Our first rational expression, the denominator is u minus 1. It is already simplified, there is no change. Also for the second rational expression, the u is simplified, there is no change. For the third rational expression, the denominator is u square minus u. We will now put the factored form u times the binomial u minus 1. And then for each rational expression, we will now to multiply by a term so that it will be equal to the LCD. Look at our first denominator u minus 1. I should multiply it by u to be equal to the LCD. So this is u, and that same variable u will be copied up here. So our first rational expression is to be multiplied by u over u. And then plus, going to our second rational expression, the 1 over u. So this variable u, I should multiply by a binomial u minus 1 to be equal to our LCD. And this u minus 1, I should copy in the numerator. So the second rational expression is multiplied by u minus 1 over u minus 1. And then minus the third rational expression. Since our denominator here is already equal to the LCD, we will not multiply anything. So let us now multiply the corresponding factors. In our first group here, the 2u times u will be 2u squared. The denominator now becomes equal to LCD. For our second group, 1 is multiplied by u minus 1. Same u minus 1 will come, and the denominator becomes the LCD. And then minus, we will just copy the third rational expression. We can now go to step 3 to add or subtract the rational expressions. We have now here 3 rational expressions of common denominator. So I can now combine the numerators. Look at the 2u squared. I copy it here, and then plus the numerator u minus 1 is now copied here, and then minus the third numerator is now here. Then all over the common denominator, which is the LCD. Let us now simplify our numerator by removing the grouping symbol. So if we do that, in the second numerator, we can directly delete the grouping symbol because it is preceded by a positive sign. because it is preceded by a negative sign, I should change the sign of all the terms inside the grouping symbol. So this 2u should becomes negative later, and then this negative 1 will become positive later. So it's now here. 2u squared plus u minus 1, and then minus 2u plus 1. Then we just copy the LCD here. Next, let us combine like terms in the numerator. 2u squared is here, positive u and then negative 2u. It is equal to negative u. The negative 1 and positive 1 cancels each other. So this is now our simplified 2u squared minus u in the numerator. In step 4, let us simplify if possible. In the numerator, I observe that there is a common factor, and that is u, that we can pull out. And you see the u, it is common to the numerator and denominator that we can cancel. So after the cancellation, we will just collect the remaining terms. So this is now equal to 2u minus 1 all over u minus 1. So the next question is, can we still simplify by cancelling the u and the u? Can we cancel also the negative 1 and the negative 1 in the numerator and denominator? There is a note that we cannot remove a term from a sum. It means the 2u minus 1 here is taken as one group. The u minus 1 in the denominator is also taken as one group. So it means this is now our final answer. Example 4. Simplify t over t minus 6 minus the rational expression t minus 2 all over t plus 6. We can see that the two fractions here have different denominators. T minus 6 is not equal to t plus 6. So step 1, let us find the least common denominator, or the LCD. So we write the two denominators, and we can see that these are already simplified. So for our LCD, simply we put together as factors. So the LCD is t minus 6 times t plus 6. Then step 2, we rewrite each rational expression as an equivalent rational expressions using the LCD. So we copy the two fractions down here. Let us now consider the first fraction. This denominator here, we want to be equal to LCD. For that purpose, we're going to multiply the t minus 6 by t plus 6. And then this t plus 6 we will copy on top, minus the second expression. Our denominator is t plus 6. We want this to be equal to our LCD. That is why we will multiply t plus 6 by t minus 6. And this t minus 6 simply we copy on top. Now we have two big groups. We will now multiply the fractions respectively. In the first group, this t multiplied by t plus 6, and we have t squared plus 6t. All over, we combine the two denominators and we have the LCD here. Then minus this t minus 2 times t minus 6. So t times t is t squared. T times negative 6 is negative 6t. Negative 2 times t is negative 2t. Negative 2 times negative 6 is positive 12. Over the denominator, t minus 6 times t plus 6. Then we simplify further our numerator. this negative 60 combined with negative 2t, we have negative 8t. Then we have the step 3. We add or subtract the rational expressions. Since we have LCD as the common denominator, we can now subtract the numerators. So, the first group is t squared plus 60 minus the second group, the trinomial t squared minus 8t plus 12, all over the common denominator. Then we simplify our numerator. Let's remove the grouping symbol. The first group, simply we can remove the grouping symbol. But in the second group, we need to change the signs of all the terms. So we have like this, t squared plus 60, the first group. Then the second group is now negative t squared plus 8t minus 12, all over the common denominator. Let us now combine like terms. The t squared, there is negative t squared here, it is cancelled out. It becomes 0. Then we combine 60 plus 8t. We have 14t, then we copy the constant negative 12, all over the common denominator. This is now the final answer.